So what secrets could this discovery unlock? For some answers, we turn to Ira Flatow. He's host and executive producer of Science Friday. It's the source for stories about science and technology. Ira, thanks for joining us. I imagine some Thursdays you're probably wondering, what are we going to talk about tomorrow? That's not a problem today. Just how big is this, and how would you break it down for ordinary folks like myself?
Well, this is huge because it's the last puzzle in Einstein's theory about gravity. Gravity is still one of the most mysterious things in the universe. Believe it or not, it is one of the weakest forces in the universe. I mean, your magnet on your refrigerator is stronger, right? It can defy gravity and not fall to the floor. So Einstein had predicted 100 years ago that it's possible to have these waves, these ripples of gravity in space. And they found it, they discovered it and announced it today. And hopefully we can start to understand just how gravity works now.
Yeah, that's the next question. Is this like a can opener? By that I mean, I watched the press briefing live this morning, and the people speaking very excited about this, but I think in some ways even more excited about the future. Does this open up even more discoveries, and what's it likely to lead to?
Well, you know, this is like a new telescope. They now have a gravity scope, so to speak. You know, they've been able to look at the universe through light. They've been able to look at it through X-rays. They've been able to look at it through infrared. You've seen pictures of it. Now we have a telescope, so to speak, using these detectors of watching gravity as it moves around the universe. And as it moves around the universe, we may learn more about how it actually works. Don't forget, the quantum mechanics is really how science works these days. But gravity does not fit into the mold of quantum mechanics. It cannot be united. It was the one last thing that Einstein worked on in the last part of his life, trying to unite gravity with all of quantum mechanics, and he could not do it. Now we have a way of looking into gravity and maybe finding a way of uniting quantum mechanics with gravity.
Ira, what about your admiration for Albert Einstein? I mean, he announced his theory back in 1915. That was the same year, just to frame this, when the House of Representatives here in the United States rejected a proposal to give women the right to vote. So clearly, back then, not everyone was forward-thinking. How did he know this without all this advanced technology?
Well, you know, he was working on this for 10 years. In 1905, 10 years before this, he came up with what he called his special theory. This is a general theory, and he worked on the idea of expanding the special theory, in which he had talked about the speed of light being constant. He defined space-time for the first time, but he knew that gravity was missing from that special theory, and it took 10 years to think about it, came up with the general theory, and now it took 100 years to make the instrument sensitive enough to detect what he predicted. So we had to wait all this time to create that very sensitive instrument.
Ira, what's the big takeaway for you? Because this is so layered. There's so much here. There's the discovery, the physicists who staked their careers to proving Einstein right. The National Science Foundation took a lot of flack for spending so much money on this research. As you look at all of this, what's your big takeaway?
I think the big takeaway is basic research, which is really what this is, because we don't have any applications for this, right? We don't know what technology is going to come out of it. Basic research takes time, it takes money, and it yields results that are unpredictable. We don't know what's going to come out of this discovery. Who knows, 5, 10, 15, 20 years from now, we may discover that we know more about dark energy and dark matter, two really spooky things that go on in the universe, because we know more about gravity. It's like kids being in a candy store for physicists.
Well, I'm not Einstein, but I will make a prediction. You'll hear more about this on Science Friday with Ira Flatow tomorrow. Thanks so much.
Absolutely. Thank you.